Hey guys, I think we're live. So because this being the final meeting, so we want to clear any doubts that you have. So if you have any doubts in Dr. Neerav's course, be it theory or tutorials, you can ask us, and we'll be here. As far as Dr. Karthik's or Dr. Himanshu's portions, I think you'll probably have a meeting tomorrow or day after. We'll confirm and let you know.
Okay, sir. Thanks. So, day after tomorrow, if you have a session at, then could you have it at some other time, if, say 8 p.m. or later? Because that would clash with with another subject that we have this term.
Okay, we'll send a timings list and may whichever works for us.
Okay.
Then we
Okay.
should
Can
be,
you put it
or we
in
should
the
any.
Google chat?
Chat space. Yes, yes, sir. I'll put that in the chat space. So tomorrow, of course, it's possible. No, no issues. At least for my subjects, I don't have any clash. But on Thursday from 6 p.m. we have a session for operating systems, and that will be a similar like a end term revision session as well. So I just hope it doesn't clash if that can be avoided.
Yeah, okay, that works.
So I had a question in the graded segment week 11 uh, for question 2. We're asked to compute the Fourier basis, right? Now, that's a 6 node graph. So the matrix will be pretty big. Now, after that, after doing the Laplacian and then calculating the eigenvectors, I was wondering if there's any faster way to do that, or if similar questions will be expected in the end term because it took a lot of time to solve that.
I mean, this one you could have used, Python to actually come to the answer. You don't, there's no necessity that you have to do it by hand. Nsen will make sure that the graph is smaller and it can be done within the given time frame.
Okay, got it.
No, there won't be any mock exam. We have already uploaded the previous year question paper, so that should be good enough.
Sorry, speaking of the previous year question paper, I think similar to quiz two, there are a few questions in the previous year paper that are subjective. But during the earlier quiz, it was mentioned that there will be now subjective questions this term.
No,
So
no,
I
no
hope the
subjective questions this term.
yeah. So
Only
okay,
multiple choice and multiple. Yeah.
okay, okay. Thanks.
I think we can go week wise. Any questions in week 7? Make sure you have enough time to go through the materials in week 7. If you have any doubts in the assignments, coding, or the lectures, you can ask us now.
Okay, there's no questions for week 7, week 8. Okay, I think this be a waste of time. So it's better if you Whatever you doubt you have, you just mention the week and then ask us instead of us going week by week. It's
So
only a few people, so yeah.
I, uh, I have a request. If so, till week 8, I think it was already covered in general in the previous vision session before quiz 2. Would it be possible for both of you to give a brief overview of the last 4 weeks, weeks 9 to 12? Could you maybe revise the concepts for these weeks in brief, especially with focus on the end term pattern?
I mean, do you want a presentation or just go through the
Anything,
topic?
anything that you prefer. You can like either a presentation or you can just go through the slides or like whichever will you feel convenient. I mean, just a revision of the last 4 weeks is what I'm asking for.
Okay, so week 9, we introduce the concept of node embedding. How do you generate a numerical representation for a node? Okay, and the theory behind generating node embedding is nodes that are connected in the graph. That means very adjacent to each other. Okay, should also be similar in the embedding space. That's the main concept. Okay, there are different approaches. There is shallow embedding. So the shallow embedding approaches, I think you might know the matrix factorization based approach, random walk based approach, and so on. And the main thing you have to remember in shallow embedding based approaches, can anyone tell me what's the main drawback of shallow embedding?
Does not take features.
Yes. Then
Um, only- that's the only one I remember.
can it generate an embedding for newer any other node that comes new for prediction?
No, only the ones it's seen there and
So
there.
you have to, if there is another node added to your graph, you might have to train the whole thing again, right? So that those are the drawbacks of using shallow embedding. And so that was your week 9. Week 10, what we do is cover a bit of edge embedding and deep learning. Okay, edge embedding, you take the node embedding, do different operations like taking summation, taking mean, and so on. Those there are those 4 operations that you can do and create an embedding for your edge. Okay, that's the thing with edge embedding. And week 10, we also cover deep learning basics. Okay, I mean, to alleviate the drawbacks with shallow embedding, we go for the deep learning based approach. And deep learning using just feed forward neural networks on graph won't work. Why is that the case? Can't use standard, feed forward neural network on graph.
Because the adjacency matrix gets flattened, so you don't have the spatial information, and it will depend on how you order the nodes.
Yes, yes, yes. And so the operations there are not permutation invariant or permutation equivariant. Okay. So permutation invariant means whatever ordering of nodes is present in your input, the output won't change. Equivariant means if you apply a permutation matrix on your, or do some permutation on your input, the output is also make sure that it changes accordingly with the permutation. So there's permutation invariant, permutation equivariant. Okay. And to do these kind of, uh, you know, to build specialized architecture for graphs, You have two main operations, okay, that you do in graphs. So one is the filtering, and then pooling. Uh, and also you mentioned that in channel embedding you can't take use of node features or edge features and so on, right? This is where we develop graph filters and graph pooling operators. What do you do in graph filters? What do you use it for? So the problem setting here is you have a graph. Each node is associated with a feature vector. Okay. So you kind of have an adjacency matrix. You have the feature matrix. What do you do in graph filtering?
Features in a lower dimension.
Why do we actually need to do that? Why do we actually need to do filtering?
It gets better features as you do more filtering.
Okay. So the idea behind doing graph filtering is remove unwanted features and make sure that you retain only essential information that can be used for your downstream task. The downstream task can be node classification, node regression, or graph classification, graph regression, and so on. Okay, you do, and there are many. Uh, there are two main approaches in graph filtering. One is the spectral filter based approach, and then there is your spatial filtering based approach. Spectral filters, what does it do? I need to explain it. It will work on mainly the feature signal. If signal, I mean the features associated with a node. Okay. You don't need to go into the depths of the spectral theory and so on. You just need to remember what are your inputs and how will your corresponding outputs be. And examples of spectral filters would include, the Chebyshev filter or polynomial filter and so on. And remember, in order for these filters to work, you also have some parameters associated with it that you learn through your training phase. All those back propagation in deep learning you have learned. So the theta values you actually learn through your process. So these are all learned filters. When you compare it with a low pass filter, there are no parameters associated with a low pass filter. Nothing can be learned. Okay. So the advantage here with Chebyshev filter and polynomial filter is you can only extract features that are important for your downstream task. Okay. You remove all the unwanted signals, remove all unwanted noise, you extract only essential information. Okay. And then the spatial based filtering, what does it do is it aggregates information from your neighboring nodes. Okay. So there are different hops involved. So if it's your one hop neighborhood, you aggregate information, aggregate in the sense collect feature vectors from your neighboring one hop, not so one hop nodes that are directly connected to each other for that particular node. You take all the features, either concatenated, take the summation, take the average. You can use an LSTM to for your aggregation and so on. There are different approaches that we have mentioned in the lecture, and then generate embedding for that particular node. So these are all spatial based filters where you aggregate information from your neighborhood and then update your original embedding for that node. Then comes pooling. In pooling, what we do is if you want a single embedding for your graph, okay, the simplest way you can do is collect all the feature vectors from your all the nodes, take the summation, take the average, and then generate a single embedding. But that won't work in general if you move to the practical scenario. just taking the maximum value, the average value, or the summation value, like your general max pooling, average pooling, and so on, those won't work. Instead, other types of pooling like hierarchical graph pooling, what does it do is it gradually reduces the number of nodes in a graph so that all the essential features are retained in your final graph embedding also. So filtering, there is no change in the graph structure, that you should remember. No change in graph structure, only the node features get updated. But in the pooling case, you reduce all the nodes in your graph so that only one final node is retained at the end that represents your whole graph. That is what the idea behind pooling is. Uh, yeah, I think so. These are the major concepts that were covered. If did I miss anything? Do you want me to explain something else? You can let me know now. Any questions and assignments? Any
So,
particular topic? Yeah.
there's a question in the chat box. I see filter pooling and other counterpart of deep learning. I don't know what is referring to, but that's there in the chat box.
I mean, filtering and pooling I actually explained, all right.
Yeah, yeah,
But I don't understand what's the other counterpart of deep learning.
yeah.
Is he
Okay,
present here?
yeah, I think he dropped off. He
Okay,
might have
fine.
gotten disconnected. I have a couple of questions which are from week 7 to 8.
Mm-hmm.
But I mean, I've already raised them earlier, but I did not get a response. I just put that. I'll share a link to that question on the chat box. It's on Discourse.
Okay.
Basically, I wanted an explanation of question 177 and 189 of
Okay.
the enter. Sorry, of the quiz two paper.
Okay. Yeah.
If you
I'll just,
open that Discourse thread, I have already put in screenshots of the question, so you can just check
Yeah,
the
yeah.
question
I'm
from there
I'm checking
itself.
it. I'm checking it. So, what exactly is your doubt here?
So for that De Bruin graph question, the
Hmm?
first 177, could you share the graph? So what I've done is I got it wrong during the exam, but
Okay.
I do it again on my own, and I think I might have figured out where I went wrong, but I don't have the actual solution to compare to. So I just want the actual graph to compare against. I just want to confirm if I have again gone wrong or is it correct. That's all.
Okay. Let me just check.
If like if you want to do it later on, that is also fine. But if possible,
I'll just check if I have
I'll
the
answer.
solution with me right now, and if I don't, I'll share it. I'll respond to this
Yeah,
by
yeah.
tomorrow.
Sure, sir. And the other part is question 189. Could you explain that thing? Because my reasoning was totally different, and I got partial marks for that. But still, if you could explain the reasoning behind that question.
Okay. So, reads from
Seems
genome
to be a
sequence.
trick question of sorts, but yeah, yeah. Please explain that.
Hmm. Okay. Reads from sequencing are prone to error, and sequence alignment can be used to overcome this problem. So, these are the two statements. The question is to find out which of the statements are not true. So, the first one is reads from the sequence are prone to error. This statement is true. Correct?
Yeah.
So, in that case, so it is false. So, that in this case, so only the possible answer is, so in D we have statement 1 is false, option
Okay.
D.
Oh,
And
okay, right.
statement,
So okay. C as well. Both statements are false, so they become correct options.
yes, yeah.
But
So in
what about the
similar,
second option?
second option, both statements are true, but the statement 2 is not a solution to statement 1. So can sequence alignment be used to solve the error problem in genome sequencing? No, right?
Um, I mean, So what I thought was that error prone reads are caused by multiple reasons, and sequence alignment is not. I mean, it is one of the reasons, but not the only reason. So
Oh,
overcoming. I
so,
mean,
so,
if you
so,
have to
okay, okay,
overcome
okay,
the
okay, okay, okay. There's small confusion. So, how do you build a de Bruijn graph or an adjacency or a graph for a Hamiltonian path? You compare the sequences, right, of the k-mers.
yeah, yeah.
So instead of saying they should be 100% 100% identical, which is what you would expect if there was no error in the reads.
Error. Hmm.
So if there was an error in the reads, then you can use sequence alignment to choose to match sequences based on the highest possible alignment score. Correct?
Okay. Okay. Yes. Yes.
So in a sense, it is a solution to this problem. Statement 2 is a solution to statement 1, but but this option is it is not a solution. So this statement is false, and therefore this option is correct. This is double negative.
Okay. Okay. But okay. Okay. Yeah. Yeah. No, okay. I get it. Yeah. This was
Yeah,
confusing.
yeah,
So, but then again, the original statement, sequential, the statement one reads from genome sequencing are prone to error. Now,
hmm,
this error that creeps in during genome sequencing, it is caused, as I said, it is caused by multiple factors. Like you can have anything that, like reading errors or errors in the instrument or whatever that be. And
correct,
genome sequencing is just one of the possibilities to solve that. Either you can, if I mean the ideal case scenario would be to not have an error at all, like 100%
correct.
accuracy on the sequencing.
But you can use genome sequencing to address that problem, right? That is the point.
Okay. And can it 100% overcome the error? I mean, say we have some error. Is it
No, of course not.
can it guarantee? Okay. Okay. Okay, sir. Got it.
Let me. So I'm replying to the discourse question because I can't send a picture here.
Okay. Okay.
Are there any other questions in discourse that are not answered yet from week 7 to 12?
GA 11 question number 4.
Okay.
This was posted in Google Spaces, but I don't think is answered.
Okay. Seems like a question was raised on week 7 GA1, but that has not been answered on discourse. Okay, I believe it was answered during the live session, but nothing came in on
Yes.
discourse. So could you please post a reply to that as well? I'm just putting the link
Yeah,
there.
let me just check.
Because generally those who post the question on discourse, they might not always be there in the live session, so at least the thread needs to be closed or responded to, also for others to see. I think he raised it out on question 9 of week 7 grade assignment.
Yeah, yeah, yeah.
So sir, the graph that you shared right now,
Yes.
that is the overlap graph, but Could you share the De Bruin graph? I mean, the one you shared that does not have 15 edges.
Oh, right,
Let
right.
me.
I'll check. I don't think I have it right now. I'll check it and I'll let you know.
Yes, sir. Okay. Actually, specifically, I have an issue. I think in the exam I made a mistake with the ATC, TCT, and CTA part. Those three cameras, I might have miscalculated something while drawing that.
Okay,
But
okay,
if you
okay.
could provide the correct solution to that, I'll be grateful.
Yeah, okay, I'll tell you. Okay. Is there? I'll answer this question. Is there any other questions?
Yeah, Cherian mentioned something right now that was there on the chat space. I think G11 question 4. Cherian, could you repeat that?
Yeah,
Yeah, yeah,
GA11.
yeah. I'm looking into that. Yeah.
And yeah, in the previous year's question paper also, I have two questions.
Yeah, I'll post the solution for GA11 question for later. What about the previous year question paper?
Do you have? Are you able? If I tell you the question number, will you be able to see it, or should I share my
No,
screen?
no, no.
Please share your screen.
Okay. Is it visible?
Yeah, it's visible. Okay.
So I had a doubt whether this is correct or not.
Okay. Yes. So it's a thing about definition. So Hamiltonian path is not defined as the path that passes through all the nodes. It's defined as the path that passes through all the nodes exactly once. So that exactly once is important. You can have n number of paths that goes through every single node, right?
Okay. Okay.
So the exactly one part is why the options are that way.
Okay. Okay. Got it.
And the other question?
That is the last question. 194. This one.
Yeah. Any doubt here?
Yeah. So the process seems to be quite long. So I was wondering if there is a easier way to do this.
Why do you think it's taking too much? You just have to multiply some matrices, right? You need to know the formula, you need to multiply, that's it, right? I think it can be done. That's not an issue. There's no shortcut way. You use the straightforward method of how to use your GCM for a single step, then it should work.
Do you have the solution to this?
Hmm?
Do you have the worked out solution for this by any chance?
I think we are not allowed to post it, but
Sorry, what?
no, we are not allowed to post the step-by-step solution things.
Okay, that seems to be new. Why is that the case? Because there's a PYQ question, right? If it were a question that is coming up in the exam or something, then I understand the justification. But what is the justification behind not showing a solution for a previous year question?
I don't think we need to share a solution. It's a fairly easy question only. We know this formula. You just have to multiply a couple of matrices.
Okay, I'll try
Okay,
with it.
but okay, if we solve it ourselves and share the solution, could we at least verify that it is correct?
You have the answer here, right?
If you
Oh,
don't
right,
get the answer,
yeah,
the
yeah.
solution.
Okay, okay, yeah.
We have shared what are which options are correct. You just need to verify it
Okay,
yourself if your
okay.
step is right or not.
Guys, but
Okay, only those two questions I had.
okay.
G11 Q4, I'll share the solution shortly.
So, would you do that on the chat space itself or on discourse?
Google Chat.
Okay, okay.
And you had mentioned that you had uploaded something, but I was just going through the folders. I didn't see anything.
Week 12 notebook should be uploaded by now.
Notebook, okay.
Yeah, please check that.
Under the Jupyter Notebooks folder, is it?
Yes.
Okay. Yeah, it's here. 12 JNN PyTorch.
Anything else?
Had
For
you
week
also
11,
uploaded the solutions for the GA from GA 9, 10, 11 and all that?
I have the solutions. I'll just ask them to upload. Yeah.
for week 11, the first question. So, the fixed ordering of nodes, why is that like not an option? Because what I was thinking is if we assume a fixed ordering of nodes, then traditional deep learning methods will fail, like FFN will fail. So, what's wrong there?
No, if the ordering is fixed every time, deep learning doesn't fail, right?
Um, could you explain it a little bit more?
If you keep maintaining the same order of nodes, let's say, alphabetically for any arbitrary graph, deep learning would still work. That's what it means. But if you keep changing the nodes order or something, then deep learning will fail in the adjacency matrix. That's what the option means.
Okay, but even if it's a fixed ordering, if we flatten it, doesn't it lose out a lot of information?
Yes, it
Like,
does lose out the
but that's
information,
not
but
failing.
I mean, it will have a chance of working. That's what I mean to say. Even if
Okay,
the ordering is fixed, I mean, the still even if we flatten it, the information is still present.
okay.
I
Even
will
if
I would give you the example of, have you learned about CNNs?
yes,
So before CNNs, what we were doing with images is, even though it's a 2D structure, we flatten it. okay, and then pass a feed forward neural network as input, then do your prediction. It still works. You
Okay.
may not be able to get 95% accuracy or something, but you might get around 70 to 80.
Okay. Got it. And another just clarification I wanted was for the polynomial filter operator, the parameters that we are learning, theta k. So those are essentially the coefficients of the lambda parquets, right?
Yeah.
So for one I, there is a set of theta k, but that theta k is repeated for all i's. So during training, do we get each theta k by seeing all the I values together, all the lambda i's together?
No, no. Yeah, I mean, so after the so filtering, the I would say, let me just show it. What do you mean by I's? Is it the identity matrix or the?
Oh, the lambda I, like the index I. I'm saying,
Mhm,
so you filter over lambda I and you get a polynomial function, right? But
mhm,
there are multiple I values, so there are multiple lambda i's. So since there are only k plus 1 parameters, if we are using it at the current index, we will be using the same parameters over all the indices,
Yes.
because otherwise number of parameters would go up by a lot, which
Mhm,
is bad.
mhm.
So for that,
So you
when
will
we
have the same one parameter for one power in your
right,
polynomial. Yeah,
right,
that
so
will apply
so
to
we
all the
see,
elements in your Laplacian matrix.
yeah, so we see all the lambdas and then we generate the theta for that
Mhm.
uh lambda k.
Yeah.
Okay, got it.
Any other questions? Yeah.
Yeah, no, I just wanted to acknowledge the fact that I saw the Elledian graph now. I'll take a look at it. I'll compare it with my solution, and in case there's a doubt, I'll raise it on the Discourse thread itself.
Okay. Okay.
Yeah, thanks for sharing the solution, sir.
Anything
Any other
else?
questions?
Okay, one general question. The ET question paper pattern. Could you tell us if it is more weighted towards the last 4 weeks, or is it like all the weeks have equal weightage?
So it will be more weighted towards the last few weeks because you already were assessed in
Yeah.
the first few weeks.
Yes. Okay. Yeah. I mean, generally that is what happens. I just wanted to confirm that it is indeed the case this time as well.
Yeah, yeah, it is.
Okay. Okay. Thanks.
Okay, any other questions?
No more questions from my side, sir. I have few doubts on the other weeks, but I'll ask them in the next live session. So,
Yeah, okay. Okay, if there's no other questions, I think we can end the class here. So, so all the best for your exams, and if you have any other questions, you can put it on Discourse or the Google chat, and I'll answer.
yeah. Thank you, sir. Thanks for the session.
Thank you. All the best,
Thank you.
everyone.
Thank you.